Hello everybody. Today we start with a new chapter in Standard 9th ICSC Chemistry. That is chapter number 4 of textbook Viraf Dalal. That is atomic structure and chemical bonding. So it is of course two parts, divided into two parts. Atomic structure is the first part of the chapter and chemical bonding is the next part of the chapter. So let's see the atomic structure first. So first of all, when we talk about the atomic structure, we need to understand the concept of the atom. So atom is that particular smallest particle which can identify an element. So that's why we can see that the concept of an atom originated from the ancient Greek philosophers. So Democritus, an ancient Greek philosopher, studied the nature of matter and the basic constituents of all the substances. So yeah, all the substances were made up of atoms, and so that Greek philosopher gave this thing. In fact, they are not mentioned over here, but even our own Rishi Karnad, Maharishi Karnad gave the thing of Anu and Parmanu. So Parmanu is the atom and Anu is the molecule. So it was given way back. So that is also one of the ancient history about atoms and molecules. So anyways, then the main kind of the conceptual changes, or we can say the main kind of study of atoms, started in the year 1808 when John Dalton gave his atomic theory. So John Dalton in 1808 proposed a theory of atom known as the atomic theory. Dalton's original theory of the atom has undergone modification, but the principal aspect of the theory are still held valid and useful in the study of chemistry. So it is just remarkable that in 1808, when there were no microscope, forget the electron microscope, at that time a person has given the concept of an atom and is given the different kind of a theory about the atom. So that's why Dalton's atomic theory is one of the major breakthrough in the study of atoms. So even if we know that partly it is correct and partly it is incorrect, we still are using this thing, or we are still following this particular Dalton's atomic theory. Only thing is we have just modified certain things which we now know that they are slightly incorrect. Okay, but we cannot forget one thing, that the inputs what he had given was at that time when there was no technological assistance to him. So based on that, whatever he did was extremely remarkable. So he gave this theory that first of all, he has given some 5 points based on which first is matter consists of small indivisible particles called atoms. Now when you say that matter is consisting of, so first thing is matter consists of indivisible. So main thing, what is indivisible particle called atom. So the matter is consisting of small indivisible particles called atom. Of course, we very well know that the present theory says that atom is divisible into protons, electrons and neutrons. Hence the word indivisible can be considered to be as wrong. But again, I would defer this thing, because if you talk about indivisible particle, now you know if you take an electron, or if you take a proton, or you take a neutron, it is not going to be identifying the element. Electron is an electron which could be of any atom. एक इलेक्ट्रॉन हाथ में लेगा, अरे ये तो हाइड्रोजन का, अरे ये प्रोटॉन तो यूरेनियम का. No, you cannot identify the element based on the electron, protons and neutrons. Hence, if we see the characteristic property of that particular substance, the characteristic property will be there in an atom and not in a proton, electron and neutron. So anyways, the point is remaining the same, that the Dalton's first theory will be that matter consists of small indivisible particles called atoms. And secondly, atoms can neither be created nor be destroyed. So of course that is the next part, and that is the atoms cannot be cannot be created nor destroyed. Now what I'll do is that I'll just go with this के जो भी the modern atomic theory, whatever is the changes which are taking place, I'll just mention over here itself. So over here we know that it is divisible into protons, electrons and neutrons, and here it is can be destroyed because it is getting converted, means it is getting broken up into smaller particles, that is radioactivity. So radioactivity is the procedure, or you can say the process by which the atom is going to decay. So that's why we can say that atom is destructible. So it is not only, it is neither indivisible, it is divisible, and it can be destroyed. Of course it cannot be created, but it can be destroyed because of radioactivity. The third thing, atoms of the same element are alike in every aspect and differ from atoms of other elements. So this is again going to be controversial, that is, atoms of same element are same. Now this is not true in case of isotopes. Now we had studied isotopes earlier, okay, even if you're not, just remember one thing: isotopes are those substances, those atoms or those elements which has got the same atomic number but different atomic mass number. That means अगर एक particular potassium है, suppose we say sodium लेते हैं, तो sodium can, we know that sodium will have 11 protons, 11 electrons and 12 neutrons in one kind and 13 neutrons in the other kind, and that's why the sodium will be available in two forms. Okay, we had learned the isotopes when we are talking about the atomic mass. Okay, atomic mass number is always in decimals वगैरह में, तो उसमें क्लोरीन का एग्जांपल लिया था हम लोग ने, क्लोरीन 35, क्लोरीन 37. तो और उसका, so you can see that chlorine 35, chlorine 37 both are chlorine, but still they differ in their atomic structure. So that's why the third point of the Dalton's atomic theory is not completely true, because there are exceptions, that are, there are isotopes which are not going to give you the same atomic number, they will be not having the same atomic structure even if they are of the same element. So accordingly we see that the atoms of the same element are alike in every aspect and differ from atoms of the other element is not exactly true because of the isotopes. Fourth point, atoms combine with other in a simple whole number ratios, forming compounds and or molecules. This is absolutely true even today. So atoms combine in whole number ratio. Okay, so this is exactly true. This is true even today. So even today, the modern atomic theory says the same thing, that atoms are going to combine with each other in a simple whole number ratio. So that is going to be true. And the fifth one is, atom is the smallest unit of matter which takes part in the chemical reaction, and all chemical changes result from the separation or combination of atoms. Now this is exactly again true, that is, atom takes part in all chemical reactions. This is true. So yeah, even today we are confirming that atom is the smallest unit of the matter which is going to take part in the chemical reactions, and all chemical changes result from separation or combination of the atoms. So this was the postulates of the Dalton's atomic theory. Yes, you will need to learn these Dalton's atomic theory postulates, because they may ask you that state the Dalton's atomic postulates. They state any 4 or any 5 or any 3 postulates of Dalton's atomic theory. Now let's see the contradiction which we already mentioned over here. So we see the first thing is that Dalton says that atoms are indivisible and indestructible, but modern theory says that atoms are divisible and destructible. Divisible because of the PEN, that is protons, electrons, neutrons, and destructible because of radioactivity. The atom is the smallest divisible particle of the element, so atoms are divisible, consisting of subatomic particles like electrons, protons, and neutrons. And atoms of the same element are alike in all respects, differ from atoms of another element, but atoms of the same element may not be alike in all respects, as seen in case of isotopes, which are the atoms of the same element having the same atomic number but different mass number. So this is how the modern atomic theory is differing from the Dalton's atomic theory. So the modern atomic theory, however, correlates with the Dalton's atomic theory in the fact that atoms are the smallest unit of matter which taking part in the chemical reaction, and in a given compound the relative mass number and the kind of atom is a constant. So that particular part, that is the second and the fourth and the fifth part, we still confirm that we are correlating the modern atomic theory with the Dalton's atomic theory. So that was about Dalton's atomic theory and the modern atomic theory. Now we come to the main part of the chapter, that is the discoveries of the structure of the atom. So for the discovery of the structure of atom, the first thing, now before the structure of the atom was discovered, it was the discovery of the cathode rays which gave the lead to the discovery of electrons. So the cathode rays which were discovered by William Crookes was the initial kind of push, or it is the initial thing which caused which helped the other scientists to discover protons, first electrons, then protons, and then neutrons. So we see that discovery of electrons came the first thing, scientist, English physicist William Crookes in 1878. You can see this thing. Now Dalton gave the theory in 1808, and this thing, the cathode ray, came up in 1878. So it took 70 years. Till 70 years, nobody knew anything about there is any kind of protons, electrons, and neutrons present in the atom. So anyways, so the first thing is that discovered. So here also in 78, he did not discover the electron directly. It was just the discovery of the cathode ray. So discovered the cathode rays. So William Crookes found that when an electric discharge is passed through a tube containing a gas at low pressure, that is 0.01 mm of Hg, low pressure, almost like vacuum. So blue rays were emitted from the negative plate, cathode. These rays were called as cathode rays. So what he saw was, if you are taking a glass tube, okay, this is a glass tube, and you are removing the air from it, so the pressure inside this glass tube is 0.01 mm of Hg. So that's absolutely almost like a vacuum inside. And then if you are connecting over here one plate and another plate over here connected like this, and you are connecting these plates to this part to the cathode and this part to the anode of the supply discharge tube. So if we connect this to the positive and the negative charge over here, it was seen that there will be rays of blue color which are going to be passing through like this. So this was the way, this particular thing what we are having is this rays what we are having are cathode rays. So the cathode rays were formed when वैक्यूम के अंदर एक पर्टिकुलर ट्यूब के अंदर वैक्यूम क्रिएट किया है, डिस्चार्ज ट्यूब के अंदर वैक्यूम क्रिएट करके वी आर कनेक्टिंग द पॉजिटिव एंड नेगेटिव टर्मिनल्स to a battery, or you can say to a supply. Okay, so when electric discharge is passed through a discharge is nothing but the supply, power supply, discharge tube. Okay, so now with the help of this cathode rays, J.J. Thomson in 1897, he studied and discovered the electrons. So what he did for this was that he took this cathode rays, okay, we just erase this, and what they did was he took two plates, okay, he took plate over here, that is a negative terminal के साथ में एक negative plate and a positive plate over here, which are outside this tube. So this was the negative part, is the negative positive part, and he found that this particular rays got attracted towards the positive terminal. So it was found that these rays got attracted to the positive terminal, showing that this has to be negatively charged particles. So J.J. Thomson in 1897 studied the characteristics of constituent cathode rays. He found that the cathode rays had the following characteristics: travel in a straight line. First thing is that travels in a straight line from cathode to anode and cast a shadow of an object placed in their path. So in the cathode rays, if there was a cathode rays going by and if I put an object in between, then there was a shadow which was obtained of that particular object. That means that these are something like light rays. These are particles which are being blocked by that particular object. Secondly, they are deflected from the magnetic and electric field. So the electric field and magnetic field were attracting or deflecting the cathode rays. And the third is that they have kinetic energy and raise the temperature of a metallic object when they fall on them. So that means the third thing was that they had got kinetic energy. It means the cathode rays had got kinetic energy, showing that there because it gave a amount of heat, or it was basically to increase the temperature of the metallic container or the metallic object which was placed in that particular thing. So accordingly, you see that these are the three things which we studied of the cathode rays. First thing क्या था कि वो straight line में travel करते हैं. Secondly, they are going to get deflected by the electric and magnetic field. And the third thing, they are going to cast a shadow. That was the first part itself, that it is traveling a straight line and cast a shadow on if the object is placed in between, and they are deflected by electric and magnetic field, and finally they have got kinetic energy over there. Hence they are going to increase the temperature of any particle or any part which is metallic part which is placed in it. So that's why, due to this particular fact, that when he placed this kind of electrodes, that is positive and negative terminals over here, he found that these one got attracted towards the positive terminal. The moment he came to know that it is attracting to the positive terminal, he concluded certain things about one of the part of the atom, that is electrons. So cathode rays, so we can see the conclusion what he made was that cathode rays consist of negatively charged particles known as electrons. So he came to know that cathode rays, because they are particles, why they are particles? Because it is casting a shadow. It is getting blocked. So that's why it is a particle which can be blocked. So there is a particle over here. So first thing is that it is a negatively charged particle. Secondly, atoms of all types contain the same particle electrons. And irrespective of how electrons are emitted, they all are identical. Because he saw that when he places this strip of different metals, he still got the same kind of result. That means each and every element has got these negatively charged electrons in them. So that was the main idea, that electrons are present in each and every particle, each and every element, and they are identical. Okay, all these electrons are identical in all ways. So irrespective of the nature of the electrode or gas used in the discharge tube, electrons are produced which have a unit negative charge and a negligible mass. Since atom is electrically neutral, it must contain some particles which are positively charged. This leads to the discovery of protons. So the third thing what he discovered was that they knew by that time that atom is electrically neutral. It is neither positive nor negative charge. If it is not positive or negative charge, and then if this one part is negative, so automatically there has to be some amount of positive charge present in it, so that electrically the positive and negative will neutralize, and hence the atom is electrically neutral. So that gave out the source, or it led to the discovery of protons. So accordingly, it was known that the mass of the electron is 1/1837 times the mass of proton. So mass of electron is 1837 times less than that of hydrogen atom or a proton. That is equal to 9.107 into 10 raised to minus 28 grams. So that's negligible mass. And the charge what is carrying is a negative charge. So negative charge in that is 1.6 into 10 raised to minus 19 coulomb. So negative 1.6 into 10 raised to minus 19 coulomb is the, so it is given as 1.06602, but you can take 1.6 also. So unit negative charge is minus 1.6 into 10 raised to minus 19 coulomb. So now we know that there was a discovery of electrons, so automatically there has to be a proton present in it. So accordingly what scientist Goldstein did was discovered positive rays emitted from the cathode, from the anode. So what he did was he took in the discharge tube, he took a perforated cathode. So he took a, यानी इसी को उसने modify कर दिया, that he took a perforated cathode. So the perforated cathode is something like this. Okay, it will be, you don't require this. There will be a perforated cathode. So perforated cathode means that it has got holes in it. So accordingly what will happen? One side there will be the emission of the negatively charged electrons, and because it is perforated, so on the opposite side there will be the rays which will be positively charged. So that is nothing but the, so these are the cathode rays and this become the anode rays. So these are the anode rays and the cathode rays. So the perforated cathode is placed, so discovered positive rays emitted from the anode, they consisting of positively charged particles, protons. It is so, if a perforated disc is used as a cathode, the positive rays may be seen traveling in the direction opposite to the cathode rays. So if a perforated cathode is used over here, then so this is perforated cathode. So perforated cathode may, if the cathode rays are traveling on this side, the anode rays will be traveling in the opposite direction to the cathode rays. So conclusion, positive rays consisting of positively charged particles which lead to the discovery of protons. So this positively charged particles were, so this were of course electrons, and now came the protons. So the protons, the mass of the protons, so these were positively charged protons which lead to the discovery of protons, and the mass of proton is 1837 times the electrons, which is 1.67 into 10 raised to minus 24 grams. And as part of the charge, so of course the charge will be equal to, charge is equals to positive 1.602 into 10 raised to minus 19 coulomb. Because anyway this is negative, this has to be positive, and the charge has to be the same because the protons and electrons, so the atom as a whole is electrically neutral. So that is how the scientist Goldstein discovered the protons. Now we studied over here, so the three things what we studied right now was the cathode ray, which was by William Crookes, the J.J. Thomson who discovered the electrons, and Goldstein who discovered protons. Now once the electrons and protons were discovered, people wanted to know, or the scientists were keen to find out, that how are these protons and electrons placed in the atom. There were many theories which came up about how they are placed. Many they were just saying that okay, it's like a plum cake. Plum cake जो है पूरा का पूरा atom है जिसके अंदर छोटे-छोटे pieces में protons and electrons are mixed together. And so there were many kind of different kind of propositions made. But one proposition which was made changed the whole idea towards this thing, and it gave us the fact that how the electrons are placed and how the protons are placed in the nucleus. So that gave rise to the nucleus and the orbits of the atom, and that was done by Sir Lord Rutherford. So Lord Rutherford in 1911 he did an experiment. So for this experiment what he did was that he took a very thin film. He took a very thin film of gold. A very thin film of gold was taken, And to this gold, so if we consider that the gold was so thin that you will be having a nucleus at the center and the electrons would be over here and like this. So this is the orbit. So if I'm seeing it like this, so अगर उसको ऐसे करके अगर मैं इसको ये समझिए एक पेज है उसको मैंने ऐसे कर दिया तो it will be like this, that the nucleus will be over here and the electrons would be like this. Now how did he find out that this was the structure? Let's see. So he took this thin film of gold and to this he bombarded alpha particles. Now alpha particles are positively charged particles. Okay, alpha particles are made up of 2 protons and 2 neutrons. So anyway, it is a alpha particle which are positively charged particles. So he bombarded certain alpha particles over here. So they were alpha particles which were being bombarded from this particular point. So these alpha particles are positively charged particles which were bombarded on a thin gold film. Now it was seen that the one in the center, they just went and returned back without any kind of issue. It just returned back. There was just repulsion which was take place. Some of them just passed through. Okay, some of them just passed through. Whereas some got deflected like this. So they got deflected like this. This one may have passed through. Then this one got deflected like this. This one got deflected like this. So there were certain which were getting deflected and certain which are going just straight. So what does it indicate? It indicates simply that the one which got deflected back was because the center contained positive charge. Now you know that this positive charge, so only a positive charge will be repelling a positive charge. So that's why the positively charged protons are present in the nucleus at the center. The one which passed through undeviated means there is empty space. This is empty space. There is nothing in between. It's empty space. And the one which got deflected, what deflection was because of the negative charge. So these were the negative charge which were present, which deflected this light, the rays towards a particular side. So the deflection took place because of the electrons which were present. So this gave rise to the structure that the nucleus is at the center, which is positively charged protons present in it, and the electrons are revolving around these in orbits over here. So this is how the structure was discovered by Rutherford, and that is Lord Rutherford studied the atomic model and discovered the atomic nucleus. He directed alpha particles towards the metallic sheet. Source of the alpha particle is radium and metallic sheet is a gold foil 1/1,000,000th of a centimeter. So it's a very thin sheet of gold. Alpha particles are positively charged helium atoms containing 2 protons and 2 neutrons, and the deflection of the alpha particles was then observed and conclusion drawn. So what is the observation? Most of the alpha particles went straight through the foil. An atom of the whole is relatively empty. So most of the things just went through the foil, that showing that the atom as a whole was relatively empty. Some alpha particles were deflected slightly. A concentrated positive charge is present in the very small region in an atom, and if the alpha particle is not close to the positive charge, it gets deflected slightly. And finally, some alpha particles were deflected by a large angle or bounced back at 360-degree deflection. That means it returned back in the path. So the alpha particles pass through very close to the concentrated positive mass. It gets deflected through the large angles, and if it is approaching at right angles, it gets deflected about through 360 degrees. So if it is exactly perpendicular to the nucleus, it would take 360-degree return path. So in this way, they observed that the central area was filled with the nucleus, which contains the protons, positively charged. There is a lot of empty space in between, and then there are some negatively charged electrons in between, which are deflecting the alpha particles slightly. So this is how the discovery for the atomic nucleus took place. So accordingly, let's see the postulates of Rutherford's atomic model. Matter in an atom is located in the space in the center called nucleus, which is associated with all positive charge of the atom, while the remaining volume being a large empty space. So matter is mainly concentrated at the center called as the nucleus, which is the positively charged particles, where all others is mainly a relatively empty space. Since the atom is neutral, sufficient number of electrons must surround the nucleus to counterbalance the positive charge and revolve around the nucleus with great velocity to confer the stability of the nuclear model atom or nuclear model of the atom. So to have a stability of the nuclear model, and there should be sufficient number of electrons, that is jitne number of protons are present in the nucleus, same number of electrons will be present in the outermost orbits, wherein the electrons will be revolving around this for the nuclear stability, because positive and negative charges are going to be there. So to make it electrically neutral, the Rutherford's model suggested in this particular form. I'll just continue in the next video.